Thank you. It is working. Okay. For those of you, I don't know who saw my talk last year or the one the year before, but this is a continuation on the same theme. My name's Anna. I'm the founder of an 11-year-old startup called Riverblade. And what we do is we do interactive software quality tools. Can we get this mic adjusted? Because that's a bit feedbacky. Okay. Okay, I'll stand further back. So our thing is interactive software quality tools, and as a result of doing that for the last 11 years, we've talked to a lot of people in a lot of dev teams, in a lot of different types of organizations, ranging from the tiniest freelance outfits up to some of the big multinationals. And we see certain patterns coming out of those conversations that I think are quite interesting, and it's kind of been focusing my mind on how we approach the whole subject of software quality and the sort of things that people do that kind of don't work and put them off the subject in the first place. So I'd like to share some insights we've had working with our customers. Sorry, I've just knocked that. Shouldn't have done that. So, typical scenario. Your team's code has some quality issues. Everybody knows it's got quality issues, and they're big quality issues. Customers are starting to notice there are 300 defects logged, and it's going up every week. So something's got to be done. It's starting to affect your company's reputation. So you need a quick fix, which is probably the first mistake. There is never a quick fix. But one of the things that a team might try to do is to deploy an automated tool to look at their code and tell them what is wrong with it. Bear in mind, it's not likely to be one thing. It's likely to be a whole host of things. So, but only when you've actually looked at the code can you actually work out what you're going to fix. Yeah, so it makes sense. And that automated tool could be a static analyzer, it could be metrics tools, it could be code coverage, it could be any form of automated tool, or a whole suite of them. It doesn't really matter. But here's the key thing. If you're in that situation, who is going to do this? Is it more likely that it's going to be one person who's sitting there being banged the drum about the problems they've had in this code base for months, years even? Or is it going to be the whole team? So another decision's made. Only you can analyze the code. You will have access to the tools. But the rest of the team, they're going to get on with real work. They're going to attack that pile of defects and slog their way through them to make the customers happy. Is that right? Or should everyone be working together to learn how to avoid the mistakes which caused the problem in the first place? And it could be a long-standing endemic problem that's built up over years, but while also doing real work. So I'm going to introduce Bill, the code quality hero. Anybody read Harry Harrison? Yay. Great fun. So I'm going to apologize to him now because I'm sure he's watching. So this sounds like a really silly and contrived example, but it does actually happen a lot. One of the companies that I worked with about a decade ago had done exactly this. They got their defects up to 300 or something. The customers started getting antsy. They hit the panic button and dropped in contractors. And then the contractors uncovered all sorts of stuff. And eventually, it took about 2 years to get that code base back on track. But one of the things they tried previously was there was somebody in the corner had been bleating on about code quality, and they'd put some stuff on their build server to try and analyze the code, and then it took too long, so they only ran it once a week at weekends, and eventually nobody else looked at it and they turned it off. So these sort of things happen all the time. There are real problems out there. We talk a lot about, in a conference like this, we meet loads of people who are innovating, doing cool stuff, who are building agile solutions, building agile legal teams even. But out there in the real world, those are not the companies that you tend to encounter. You tend to encounter these big organizational monoliths who are really getting themselves into a mess. So if you're that hero, that one guy in the corner, it can be a pretty dispiriting experience. And that's just going to be amplified if your colleagues keep adding to the volume of stuff you've got to deal with by making the same repeatable mistakes. I've said this before, but I think it's worth repeating. Code quality tools are bringers of bad news, right? They don't, unless you're in a really progressive organization, they don't generally give you good news. You know, which is more likely? Your average cyclomatic complexity has gone down by a factor of 0.01. Let's give everybody a bonus. Or you found 10 potential crashes this week. So they bring us a bad news, and we tend to resent that, which is only human. They point the finger at us for not doing it right the first time. So this really is a people problem. There's a reference. Anybody read Coding Horror? Okay, Jeff Atwood wrote a blog post called The Two Types of Programmers, and I think this is always highly relevant. He basically he broke programmers into two groups. The alpha people, the change innovators, the ones who go off on courses, who read blogs and want to change the organization, and they're about 20%, and the other 80% who are career programmers. They just want to get the job done. Nothing wrong with that, but they have a different set of priorities. And most teams will, unless they're very, very carefully selected, are probably going to follow a similar pattern. So when you're trying to change anything at all, especially something which involves pointing a finger at the team, saying this could be better, you are going to get a very mixed response, and it's going to be very personalized based on the people in that team. But on average, if you've got a team of 10, you might have 2 people who are going to be receptive to that message, and the other 8 are going to be, I don't care, it's not my job, I'm too busy, we've got this deadline, you know, I don't understand that, the documentation's very good, there's too much data, any number of excuses. We have to overcome that if we want to make effective use of these sort of tools. Dave Farley this morning talked about feeding people while introducing change. That's actually a pattern in Linda Rising's, and I forget the other author's name, something man, book called Fearless Change. It's called the brown bag pattern, and it really does work. If you want to change an organization, feed people and get them out of their normal environment. So if you're going to be on the receiving end of bad news, you've got a defect, potential crash, behavioral change, whatever, that news can come in different ways. If it arrives centrally and is broadcast for the whole team to see, possibly wider than the team, it depends on how your systems are set up, that's potentially going to have a much greater impact than if you get that message at your own desk. Imagine a world where, for example, you couldn't compile anything locally. You have to commit it to source control, and the build runs on your CI server, and then it tells the whole team that you've broken the build. Would that be a welcome development, or would that be a regression? Because that's what typically happens with code analysis tools and other forms of quality tools. It's any form of bad news, any form of warning is going to be much more useful if you get it before you commit the code in the first place, because the barrier then to fixing it is much lower. And also the information is much more context sensitive. You've got it inside your development environment. I will come back to that later. So, given that we've got our 20% of devs who are likely to want to change things, our 80% who probably won't unless they're led or incentivized in some way, what are the ways that we can encourage devs to write cleaner, more efficient, more testable, and all the other good things code. Well, fundamentally, this is a people problem, as I said before. So devs are going to be more interested in writing code in a different way from the way that they have done so before. And I think that's key, if they think it's going to make their job easier. Because nobody wants to make their job harder. So if you look at it the other way, it's that change makes your job harder. So how do you mitigate that change? How do you take that hardness away and offset it by easierness somewhere else? If they've got the tools they need to do that, what do they have? What do they need? And if they know how to write cleaner code, so does the environment actively encourage learning, or do you not get time to learn? Can you do side projects? Can you do refactoring as you're working on a task? If not, you might find organizational changes would help. We can look at this as removing or sidestepping unnecessary barriers to change. So, just to summarize that part, those barriers could be organizational, so deadlines, culture, procurement. And don't underestimate procurement, because that's I've just touchscreen laptop. Because if it takes you a long time to get hold of a tool that you need, or even you have to seek approval to install something that's open source, or to even compile it and run it, which I've come across as well, then that's a big barrier. There could be technical ones. You could be using a particular tool that's the wrong tool, or it's badly configured, or you need something that does something to sit alongside it, and that takes time to research. They could be personal. There could be a lack of education, training, or experience. That one, at least, is relatively easy to solve. It just takes the same approach to training, to mentoring, and to personal development that we would apply in other areas of the organization. If you put, if you applied an iterative problem-solving approach or a lean approach, like Melissa was talking about in her session earlier, if you applied that to training, what would that do? Interesting question. But the more you can do to encourage people to learn and to train, to self-learn in particular, the more likely they are to want to learn new skills. The more likely they are to innovate in facing the problems that they normally deal with on an everyday basis. Okay, so I mentioned earlier the team that put an analysis tool on their build server. Just to give you some context, because I'll use it as an example, this was a company that had a large C++, it was a monolithic suite of tools working in a particular engineering sector. I won't name them. And they had a build that took, on a dev machine from cold, about 2.5 hours. So this is 10 years ago, so we're talking P4 days. And their build took about the same length of time on the server, because their build server was a cast-off dev machine that was slower than the dev machines. So it wasn't exactly quick. Continuous integration wasn't even on the horizon. They built once a day, then the build failed, and then they pointed the finger at who failed the build. In the background, they were running a code analysis tool once a week because it took 7 hours to run. And then everybody was ignoring the results. Eventually they turned it off because everybody was ignoring the results. There was too much, and it kind of illustrates, I think, one of the fundamental limitations with the conventional way of dealing with analysis tools or any form of code quality tool. So you run it on the build server, everyone can see those results, which is great for reporting purposes if you're wanting to monitor stuff. But you've got all these results. You might have, 250,000 issues reported in your code base because you haven't tuned the warning policy correctly. which is what I was talking about last year, you have to look at those results and actually make something of them. So who's going to analyze those results? Do you have somebody on your team who's going to do it? Should you fail the build? And if you should, what criteria are you going to use? Are you going to go for 0 warnings? Less than last time? Maybe less than a predetermined threshold? It's I mean, the whole thing about failing builds is a minefield, and it's really team dependent and hard to get right. But I would say that if your policy says that any commit which makes the quality of the code base significantly worse should fail the build, I think that's probably as close as you're going to get. Conversely, you could reward people for making it significantly better, but you know, that's team dependent. The second problem is that there may be too much data for the team to act upon. Now, I say 250,000 warnings as an example, which is probably not that unusual. We deal a lot, one of the sectors we deal with is games companies, and they have a particular combination of characteristics that make this a bit of a code quality minefield. They tend to have very young teams. They tend to have teams comprised of senior developers who've only worked in the games industry, so have never had experience of other sectors. So they've grown up in a young team environment and grown old within it. And they also tend to be they tend to have a habit of turning everything on and wallowing in data and performance and stuff. So you might find one of the customers we dealt with had a code base that was 500,000 lines of code, which is, you know, okay. And it had 5 million reported issues. When they said that to us, we said, well, turn your warning policy down because you've got too much data, you will never get through that. Turn it down to the bare minimum, work out what you care for, and then refine it. The third problem is that the analysis results on a build server can only reflect committed changes. They can only reflect the stuff you've actually checked in, which is what I was alluding to before. So I think that's huge because it means that anything that's been identified requires an additional commit to fix it. So you've got 2 changes. You've got the first change that maybe added a feature or fixed a bug, and the second change to put it right or to get it to production quality, where in actual fact, that second change should have happened as part of the first one. As a result, that means that second change, in a lot of cases, probably won't happen. Deadlines, pressures of work. There's always going to be that temptation to defer fixing that bug or fixing that warning that you've just introduced. Incidentally, I don't want anyone to walk away with the impression that I have I think that centralized code analysis or code quality is a bad idea. It's not, but I think it's only part of the solution. So just to put this into a principle, before committing, testing, analyzing and reviewing changes is likely to result in cleaner, more reliable code. So this is like if you've ever worked in an environment where you do code reviews before you commit, look at this as part of that process. Analyze the code. Run it through a complexity analyzer or something. Just make sure it's up to the standard that you think it is before you actually press the button and commit. That means learning and practicing test-driven development has been reiterated many times. I don't think I need to say much more about that. Or possibly being honest about why you don't and where you don't. If you're using private repositories or DVCS like Git or Mercurial, this all really applies before you push to trunk. But again, the earlier you commit, the earlier you analyze, the more likely you are to do it. If you say, well, I'm going to commit it to my private repo, and then I'm going to analyze it, and then I'm going to push it to trunk, I bet you miss that second step out a lot of the time. So the earlier you analyze it, the earlier you look at this code honestly, the earlier you review it, the better your results are likely to be. If you do this right, and you do it over time, it's just one of the things you can do to help the quality of your code base to improve over time, rather than collapsing into the industry standard big ball of mud. I did a little lightning talk a couple of years ago at the ACU conference about code metrics, and about one metric in particular called average cyclomatic complexity, and I think it's worth sharing this again. But I went back, somewhere along the way, we started measuring cyclomatic complexity for every build, and it's the number of paths through a function on average. Quite hard to gain, but it gives you a good indication of how complex your code is as a function of time. And we went back and we looked at the first build that we released as a public build, I think it was, and we looked at the current state of affairs, and I think we came to the conclusion that the current build at the time was like 8 times bigger, but it was less complex than the first build. I think any form of code quality measurement, that's what you want to be aiming for. It doesn't matter how big the solution gets, it's how complex is it, how maintainable is it, how testable is it. If you can compare to some point in the past and say that the metrics are going in the right direction, you're doing okay, you're doing better than most of the industry. But of course, everybody needs to be engaged in this. It's not just Bill, the code quality hero. So if you're analyzing stuff locally, if you're testing things locally, if you're reviewing things locally, what sort of environment, what sort of tooling are you going to need? And this is all, these things are all independent of whatever you're doing, whether it's analyzing code using a static analyzer, whether it's running metrics tools, it's whether you're running test tools, it doesn't matter. But these are just some of the things that I think are worth thinking about. So it obviously needs to be local to you and your working copy of the code outside of the repository. You need to have the command line, definitely. You probably want an interactive console or maybe something in your dev environment. So just make it flexible. You might want incremental analysis with a code analysis tool, definitely, because reanalyzing the whole lot could take ages. So you want it to be fast. Can we use CPU cores if we've got time-consuming stuff? Can we use the cloud, maybe? And it needs to be self-explanatory. A test failure that doesn't make sense is like, a C++ template meta-programming error with an O3 compiler. If you can't decipher it, it's not helpful. And it's just going to get turned off. So, I mean, no tooling is ever going to be perfect, and it's always going to be very user dependent. In terms of every developer has different preferences, slightly different needs, so don't be afraid to customize things and allow them to vary a bit across the team. What really matters is that we're getting better code. I don't care if one dev is using one configuration, if another dev is using another configuration, as long as they have the same results. Okay. I think it goes without saying that, and this comes back to the 80% programmer thing. If doing nothing is easier, that's going to be the default position of most teams. If you make it too hard, people are going to give up. If you do it well, although you have to take into account all sorts of technical, organizational, and people problems, it really can have benefit. Changing the way we work is never going to be an easy thing to ask. But I think it's worth it if it has the potential to help our customers and make our lives easier. And I think actually we talk a lot about helping customers and engaging with stakeholders and stuff. I don't think we talk enough about making our own lives easier. when we're selling concepts like TDD, like Agile and code quality and anything like that. It's worth thinking about, I think. The next time you're engaging with somebody on your team who's saying, who's being skeptical about changing something, find out where their priorities lie. Find out what is holding them back. Is it fear? Is it deadlines and perceived pressure? Is it something else? Because everybody's got pressure. Everybody's got priorities and ways into a problem. We're all different. Changing the way we work is never going to be an easy thing to ask. But I think it's worth it if it has the potential to help customers and make our lives easier. And obviously, any change is going to be risky. But if you don't have risk, you won't have any change, only decay. And obviously, the more team members who are focused on such a change, the better. Heroes can only do so much alone. And without support, even they are going to give up eventually. So just to summarise, I'm trying hard to not go over this year. Centralised analysis, I think, is great, but it's not as good as the real thing. Give your team the tools it needs. Give them the ability to tweak their processes and evolve them over time. Even code quality heroes like Bill need backup. And don't let them struggle on alone. All team members have a part to play, and a big part of this is trying to find a way to get to those team members who aren't focused on improving things, to try and find out what their priorities are, what will incentivize them to think about the problem and how they can help change things, improve things. And finally, if you want to talk in detail about what interactive analysis is really all about, I'm here for 2 days. Thank you. It doesn't really matter, but what sort of environment are you in for us? .NET. On the static analysis side, there is, I'm aware of, apart from FX Cop and StyleCop from Microsoft, Gendarme, I think, is the one, and also Tix will do C# as well. On any of them. But I mean, whatever tool you've got running on your, if you look at what you've got on your continuous integration server, it will give you part of the story. But what can it do for you locally before you commit? And that's a more interesting question. If you're running, if you're running code metrics in Jenkins using Source Monitor, that's great, but you could run that locally in your dev environment as well. By the time you've committed that piece of that bug fix or that new feature that's increased the complexity of the code base, you don't want to go back and refactor it because you know it's working and people are testing it. You don't want to risk breaking it. So wouldn't it be better to find that out before you commit it than afterwards? Now, it applies to any tool. Obviously, it's harder if the tool vendor only supplies one type of implementation, or if there's no way of customizing it to make it local. But I think it's a general problem rather than a tool-specific one. Okay. Any other questions? No. Thank you very much.